As we move into Unit 6, dealing with exponents and logarithms, we'll have to have some skills in using our exponents. So as a review here, we'll go through some of the basic rules for exponents. I will write the general form, and then we'll do an example down below. So first, the zero exponent rule, and that's very simple. This simply says that anything raised to the power of 0 will equal 1, okay? So we take an example of that. We can see 3 to the power of 0. Well, that equals 1. We could take 5x to the power of 3, y to the power of 4, and take that whole thing to the power of 0 and reduce down just to 1. That's the zero exponent rule. Next, we have our negative exponent rule. In our negative exponent rule, it says that a negative exponent in the numerator will get moved to the denominator and become a positive exponent. So in the case of a to the negative n, we can simply move our negative exponent in the numerator down into the denominator. Negative exponents in the denominator also get moved to the numerator and become positive exponents. So it works both ways, but we remember only to move the negative exponents. So as an example, 5 to the power of negative 2, simply 1 over 5 squared, which equals 1/25. Another example, we could have 4x to the power of negative 2. This is equal to 4 over x to the power of 2. The product rule for exponents says that to multiply two exponents with the same base, you keep the base and add the powers. So here we have two exponents with the same base, a to the power of m and a to the power of n. And in order to multiply those, all we have to do is keep the base and add the exponents. So we'll see an example of that with x times x to the power of 5, simply x to the power of 5 plus 1, which is equal to x to the power of 6. Another example, y to the power of 4 times y to the power of 9 is equal to y to the power of 13. And there you have the product rule for exponents. Okay, the quotient rule, really just the product rule in reverse. Here we have an exponent with the base and the same base it's divided by, and the result of this is simply a to the power of m minus n. So when we divide two exponents with the same base, we keep the base, subtract the powers. Very similar to reducing fractions. When you subtract the powers, you put the answer in the numerator or denominator depending on where the higher power is located. If the higher power is in the denominator, put the difference in the denominator, and vice versa. This will help avoid negative exponents, and we will see a couple of examples of what that means. First, an example with the greater power in the numerator, x to the power of 5 over x to the power of 3, simply x to the power of 5 minus 3, which is x squared. Now an example with the larger power in the denominator, we could have y to the power of 4 over y to the power of 9. This would be equal to y to the power of 4 minus 9, which equals y to the power of negative 5, or we could say 1 over y to the power of 5. Okay, our last one is the power rule, or what we call powers of powers. And just write our basic example here. We have some base raised to the power of m, and then we're going to raise that whole thing to the power of n. And the result here is a, and we multiply our exponents. This says that to raise a power to a power, you need to multiply the exponents. Okay. An example here using numbers, we have x to the power of 5, and we want to raise that to the power of 4. We simply have x to the power of 5 times 4, which is x to the power of 20. Another example of this, if we stretch it out, we'll do a bit of a more challenging one. We have 2x to the power of 4 times y to the power of 2, and we want to raise that whole thing to the power of 3. So I have to remember to do each of my terms is now getting raised to the power of 3. So this is equal to 2 to the power of 3 times x to the power of 4 times the power of 3 times y squared times the power of 3. And we can simplify that. It simply comes out as 2 to the power of 3 is 8, x to the power of 4 times 3 is x to the power of 12, and y to the power of 6. All right, there you have some notes on the rules for exponents. If you would like to do some more practice with those for your prerequisite skills for Unit 6, you can check out page 308 and tackle number 3 and number 4 there. Enjoy. For our prerequisite skills for Unit 6, we want to be able to know and understand what's happening with exponential graphs, the graphs of exponential equations. And so page 308, number 1, has asked us to consider the graph of y equals 3 times 2 to the power of x. I've gone and made myself a little table of values. We're going to find out what's happening here, the value at x equals -2, -1, 0, 1, and 2. And I'm just going to go ahead and sub each of those in to my equation here. We'll start with x equals -2. This is 3 times, remember our rules for exponents. If I have a negative exponent, I simply have 1 over 2 squared, which is 4. So here we have y equals 3/4. Sub that into my table. Next, I'm just going to use the function notation here so that it's easier to keep track of. I'm subbing in x equals -1. So we have 3 times 2 to the power of -1, which is equal to 3 over 2, or 1.5. Then we have f of 0. Anything to the power of 0 is 1, so that equals 3. We have f of 1, where x is 1. So now we have 3 times 2 to the power of 1, which equals 6. And when x equals 2, we have 3 times 2 to the power of 2, which is equal to 12. So I have my table of values here, and I'm going to just squeeze my graph in right there. It's not going to be super exact, but I'm just going to plot in some values here. So over here at x equals -2, I've got 3/4, which is less than 1. And then I've got a number that's twice as big, 1.5. I'll just put it in there. At 0, we're at 3. So again, I'm doubling my value here, 3/4, 1.5, then 3. Then I'm at 6. Here at x equals 1, and here at x equals 2, I'll be at 12. And so I can trace that line. And there you have a simple sketch, a simple example, the graph of y equals 3 times 2 to the power of x. I'm going to squeeze b into this little area here. B asks us to identify the domain. the range, and an equation for the asymptote. Okay, first the domain. Well, there's no restriction on the domain here. I can sub in any value of x here. So there's my domain, x element of the real. The range, turns out that this 2 to the power of x, no matter what I sub in for x, whether it's negative or fractional or whatever, it's never going to be negative. It will get small, 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 small. It will get very close to 0. It will never reach 0. So I'll always have 3 times that positive number, which tells me that my range is going to be y element of the real, and y will always be greater than 0, which also gives me my last information, the asymptote. The asymptote for this one occurs right here at the x-axis, which is y equals 0. So there are some key features of this exponential function.